Hello everyone. So I'm doing question number 9, which in section 14.3, which is asking to evaluate this integral where r is the disk of radius 2 centered at the origin. So whenever you're doing this kind of problems, make sure you convert from rectangular to polar, just to make the problem easier to solve. So if you take a look at the textbook, it gives you these formulas. You just kind of memorize them by heart, where you have x and y and r, and don't forget the dA formula. Most people tend to forget the r here, the extra r, which makes a huge difference in your solution. So we can start off by solving this problem. I think you guys are pretty comfortable with drawing circles at this stage. So I draw my nice little circle here. It's with radius 2, and we can start solving the problem. So we can see that theta is going from 0 all over to 2 pi, right? So we're going from 0 to 2 pi, and we can see that r is expanding from 0 to 2. So we're kind of scanning along this 2 pi direction, and we need a limit, a thing that limits us in terms of length. So our length is going to be from 0 to 2, and then you're going to have to imagine that we're moving this way. So we're scanning the first quarter, and then the second, and then the third, and then the fourth. So we can build our integral by saying we're going from 0 to 2 pi and going from 0 to 2. Yeah, that's right. So we're going from 0 to 2 and from 0 to 2 pi. We have 3 y dA. But we still need to do some work for this guy to convert it to a polar form. So we still have the same limits of integration. Make sure you have pi on the outside, and then r on the inside. So 0 to 2, 3, and then we can use the formula here to substitute for y. So r sine theta, which is the same as y, and then we can use this formula to substitute for dA, which is going to give us r dr d theta. And then we can go ahead and solve this problem simply by starting to integrate the inside and then going on the outside. So we have 3 as a constant of integration. Then we can integrate from, I'm going to be doing all the intermediate steps, so 0 to 2 pi, 0 to 2, r squared sine theta dr d theta. So we're doing this first. So we have r squared, and then sine theta is just going to be dealt with as a constant. So we can say that this is equal to 3 integration from 0 to 2 pi 1 over 3 r cubed sine theta, and it's going to be evaluated from 0 to 2 d theta. So what do we have here? We need to sub in 2 into r. So if you sub in 2 here, it's going to give you 8. Then we can move on the constants to the outside. So we have 3, then we have 1 over 3, then we have the 8 when substituting 2 here. Then we can do the other integration, which is basically sine theta d theta. well, if you know calc 1, or basically sine theta is just going this way from 0 to 2 pi, right? So the top half cancels the other half. You can just basically say that this is equal to 0, or you can do it analytically and solve it. So we have 3, we have 1 over 3, then we have 8, then we have cos and minus cos theta evaluated from 2 pi up to 0. So what do we have here? We have 3 multiplied by 1 over 3rd, 8, negative cos 2 pi plus cos 0. And this is going to give you 0.